Hi everyone, this is your host Annie Zhang, and this is Hello Metaverse. This past week has been a buzzy one for the word Metaverse. The Facebook family of apps have been officially rebranded as Meta, and they have officially announced their strategic focus to help build the future of the Metaverse. I think this move has prompted a lot of questions around what this means for the industry, how Facebook will play a role in fostering it, and really just more murmurs on what exactly even is the Metaverse. I think there is no better guest to feature this week than Jacob Navok. Jacob is the co-founder and CEO of Genvid, which is the leader in interactive streaming technology. They are working on one of the most interesting problems in pursuit of this Metaverse vision, which is how do you get millions of people to concurrently be participating and interacting in one experience with no latency? So in non-technical terms, no delay or lag. This is as opposed to what's happening right now with server sizes of around 50 people in, say, Fortnite games. For those of you who've read Matthew Ball's Metaverse Primer, and if you haven't, highly recommend, Jacob was the co-author of the networking and compute articles, which outlined the technical and infrastructural limitations and challenges that we have today to make the metaverse a reality. And we will walk through a lot of those core concepts in this interview. Beyond the buzz around what kinds of new use cases and consumer experiences the metaverse will enable, it's important to think about the foundations. What is the infrastructure and computing power that we will need to actually power this future where we're going to be spending a lot of time online together? This is not something that will be solved by any company alone, but a collective effort of all the builders for the internet. More about Jacob. Prior to founding Genvid, he led worldwide business development and strategy at Square Enix Holdings, reporting directly to the CEO. He also built the cloud gaming division, Shinra Technologies, where he met many of his current Genvid colleagues. As a disclosure, all opinions and points of view in this podcast are my own. It does not represent the views of Roblox, my current employer, and is not affiliated with the company. And here is my conversation with Jacob Navok. So you've spent a third of your life in Japan working in the gaming industry. What did you do there? What did you learn? And how did it lend itself to the creation of your current company, Genvid?
It's a good question. So I first moved there a long time ago to be a Japanese government scholar. Then I worked in Japanese finance for a while. And eventually I joined Square Enix, specifically working for their CEO in the holdings company, which is the parent of the Square Enix group. I ran worldwide business development and strategy, and I also worked on their cloud gaming business for many years. In fact, I established a subsidiary for them called Shinra Technologies that was named after the evil corporation from Final Fantasy VII. So I'm the only person in the world who can say legitimately that he was senior vice president of Shinra. And so I had spent close to a decade looking at cloud gaming at the behest of Wada-san, who was my boss. And it's very funny how it came about, because I remember in 2009 sitting in a meeting room and we had a cloud gaming company come to visit, and they showed us Final Fantasy VII streaming to mobile phones and streaming to various very low-end computers. And Wada-san pulls us into a meeting afterwards and he says, I think that the future is here. Find me the company that's going to help us create the next great Final Fantasy. And there was a reason for that specific phrasing. See, if you look at his shareholder letters in 2004 and 2005, he's talking about the future of games as the network. When he joined Square, one of the major initiatives that he greenlit was Final Fantasy XI, the first Japanese MMO. And by moving positional data from a local instance of the game to a server, we created a new type of game genre. But more importantly for the company, we created a new type of game business model, which was subscription, which hadn't existed for Square up until that time. In fact, if you look at the financials for Square, it was very clear. Almost bankrupt, release a Final Fantasy, get a ton of money in, put all that money into a Final Fantasy, go almost bankrupt, release a Final Fantasy, and it just kind of went up and down like that. And then the monthly subscription that they got from 11 stabilized it. So by the time he's looking at the opportunity close to a decade later, he's saying, well, FF11 brought us positional data. What if we had rendering and AI on the cloud and we were streaming it? What kind of new content and business models could we enable? So he had me go and research that. I looked at every cloud gaming company that was around at the time. There was Gaikai and OnLive and others. And I said to him, None of these companies are going to do what you want. There's not going to be a next great Final Fantasy coming out from Simple Encoding, but it's an opportunity. So we established a research division that I ended up running to look at what you could do with cloud gaming. That eventually became Shinra, and that former team from Shinra became my current team here at Genvid.
That's awesome. And I'm really eager to dive into what we're moving towards beyond cloud gaming. But before we get there, you have been an instrumental part in the definition of the metaverse. So you and Matt Ball, who is a well-known thought leader in the space, created the blog series, The Metaverse Primer, which has been a seminal piece for the industry. Can you tell us what your definition of the metaverse is?
Sure. So Matt and I spend a lot of time debating particularly the nuances of this. But for us, the most important pieces are that it is a massive, persistent 3D connection of worlds that have significant scale and that also are synchronous, which means that you're kind of constantly connected to them like a huge multiplayer experience. This is fairly different than a lot of the decentralized definitions of the metaverse or the phrasing of a metaverse or the phrasing of basically any video game as potentially being a metaverse. We're particularly concerned about those kinds of definitions because we tend to see the metaverse as an evolution of the next generation of internet. And so it's kind of like saying that YouTube is an internet. That doesn't make sense. YouTube is a platform on the internet. Roblox is a platform in the metaverse. Fortnite will be a platform in the metaverse, et cetera, et cetera. And the metaverse is not here yet because we haven't solved a lot of the problems that it takes to get there. So our definition is based around that very strong philosophy of what that next generation internet can look like, how long it's going to take to get there, and the hard problems we haven't solved yet.
And can you actually elaborate more about why, for example, blockchain is not the future of how the metaverse will be positioned?
I'm not necessarily sold on the idea that decentralization is part of the definition of the metaverse. I think that this is very important because if you look at the way in which I defined it, it is about real-time 3D rendering at mass scale. Blockchain is part of the internet today. It is redefining what it means to have finance in the internet today. It doesn't necessarily have anything to do with the metaverse. It can be part of it, just as you can have other things that are part of the metaverse. But I don't have decentralization as part of that definition, right? I have 3D rendering in real time at mass scale as part of it.
That makes sense. And also, I think this is not even a huge part of what you write and what you push out, but what about AR and VR? Because for the mainstream, that has been the pioneer vision or definition of the metaverse.
Yeah, it's a very good question. And I think back to a speech that Wada-san gave at Tokyo Game Show in 2011, where he described the advent of game technology like a clock. And he said, at 12 o'clock, the primary moving force of the tick-tock of game progression was processing power. If you look at the evolution from arcades to consoles to mobile devices, it was the reduction in the cost of processing power that drove visual fidelity and business model in the industry. What does this mean? It means that, as an example, you could never afford an arcade cabinet by yourself. It cost thousands of dollars, and the processor in it was optimized for a single game product. So the way in which the business model and content model worked was we sold arcade machines to people who owned spaces. They basically then rented it to the users at 25 cents a play. This changes with game consoles. As chipsets get cheaper, you get easier access to chips that can perform a wide variety of different games. They're not specialized anymore. Your Atari, your Famicom are all capable of running myriad different types of game products and aren't limited necessarily to one specific type of experience. They're also materially cheaper. And so as a result, the reduction in the cost of processing power enabled new types of game genres. The RPG, while technically feasible in an arcade cabinet, wouldn't have made sense from a business model perspective. You don't necessarily want to have a single person playing an arcade cabinet for 80 hours and being able to do that on a single coin. That's bad for business. In addition, you couldn't really save state in an arcade cabinet very well. So what happens as you move toward consoles and cartridges is the advent of batteries and other things that allow for you to have platform games, RPGs, other things that wouldn't have made sense in an arcade setting. The cheaper that processing power gets, the more the marketplace for games evolves because you don't have to pay a significant price to get into it. Your price to get into games in the 1970s was spending thousands of dollars on an arcade cabinet. Your price to get into games in the 80s and 90s was spending hundreds of dollars on a game console. Your price to get into games by the time we got to the iPhone was almost nothing because you'd already bought the phone and it was able to play games of a certain quality. So the cheaper that the cost is, to be able to play games, the more that the market increased, right? If you look at the evolution of the game industry over the course of the last 4 decades, it doesn't look like a series of shifts. It looks like geological strata, where arcade gets built upon by console gets built upon by multimedia devices. What I mean by this are PlayStations that can run DVDs and eventually Blu-ray, mobile devices, etc. And so the first tick of that clock was always processing power. The second tick of that clock, and we started to see this close to 16 years ago, was input. What drove the evolution in the mid-2000s to the mid-2010s? First, the Wii, right, and your ability to play games with different input devices. And 2, touch, whether it is DS touch or whether it is mobile game touch, the ability to use your fingers, which are easier for most people than joysticks, is a fundamentally simpler and more mass audience way of interacting with entertainment. The third tick of the clock for Wada-san was output. Output for him, he defined as goggles, glasses, etc. And now we're starting to get to the question that you asked about. You see, VR technology is a different way of viewing game content, but it doesn't change the underlying technical architecture. It's not like you're necessarily using a GPU differently or you have a vastly different sense of touch into it. You're still using mostly buttons and triggers to move around in virtual reality. And so it is a change in the way in which we view it, but it isn't necessarily a change in the way in which we manage processing, manage input into it, etc. The last tick of the clock was network. And this, for me, is the big one. That's what allows for online multiplayer games. We started to see the tick of this clock move slowly in the mid-1990s as we began to have LAN games and EverQuest, WoW, Final Fantasy XI. But even games like League of Legends, mobile titles, such as what Supercell creates, etc., are all possible because of the network, are all possible because of multiplayer gaming. This tick of the clock is the one that changed the industry the most. It is the one that allowed for radical new business models, instant access to content, the ability to have saves on the cloud, all the things that we take for granted. You could not have almost any of the top 20 game titles today if they weren't online. And that's where the biggest change in it has happened. So it's not to say that virtual reality or augmented reality don't have their own ability to create niches of content. But I don't think that output fundamentally changes what the opportunity metaverse is. I think it's the network and the scale of the network at a much radical higher velocity.
That's an incredible breakdown. And I almost feel like it could be safe to argue that network has to happen before output, right? In some ways, because you're talking about a much more higher fidelity experience. And we don't really need that. I don't think there's sufficient demand for that from consumers.
I agree. And if you look at many of the top titles of the last few years, whether it is Minecraft in the early 2010s or Among Us, fidelity is not necessarily what drives demand from the audience.
Definitely. Well, so let's dive more into your idea of what this network empowers. So your company, Genvid, it's focused on something called massive interactive live events, or at least that's one component of a use case. And it definitely lends itself to figuring out how to solve the concurrency problem in the existing network and computation limitations. Can you tell us what does that experience look like to you viscerally?
Sure. So I want to attack the question from 2 perspectives of problems that I see. The first perspective of problem that I see is simply the limitations of traditional network multiplayer. When you are playing a game of Fortnite, you're there with 99 others in a battlefield. Now, we could probably push that to 150 or even 200, though the gameplay design isn't necessarily more interesting once it gets to higher numbers, which is why they haven't really pushed in that direction. But you can't get it to 100,000. You can't get it to 1 million. There is a limitation to the number of people who can connect to a server because the way in which games were basically developed through a series of band-aids. We move your positional data to a server. The server then tells other people in the network connected to it where you are, and then handles all the traffic between it. If you have a traffic cop on a road, and he sees that you and I are trying to cross the street, he will make sure that he coordinates for you and I, and he can probably handle 2 people. When you have 3 people trying to go in different directions, shouting at him different things, it gets slightly more complicated. When you have 10 people, even more complicated. At 20 people, I don't think he can do it anymore, especially if they're not all walking in the same direction. Now, servers have become more robust, and they can certainly handle more than 20. But the point here is that the more you have attached to it, the more that you have to share data between people, and the more you have to share and coordinate that data at a very low level of latency, tremendously low. Because when I fire a bullet, I want to make sure that that hits. And if it doesn't hit well, we get really upset. We call that lag, and we blame the gods of the internet. But these are real physical limitations. Now, we should be able to design for internet connections that will get us to several thousand. And indeed, many years ago, we had PlanetScape that connected to 2,000. And EVE Online can connect to more. But the more that you connect people in the current iteration of these networks, the slower the gameplay gets, the more sacrifices and band-aids you have to put on it, because the internet was just not developed for true real-time communication of the level of latency and packet routing that we have today. The way in which the internet was developed was I open up Facebook, I load up a Facebook page, the server sends that data to me, and it doesn't necessarily need to be in 10 milliseconds or less. It doesn't matter there. So what was it optimized for? Cost? Routing efficiency? I could be living in New York, my server could be in Chicago, and it could route the packet through Los Angeles because it's cheaper. If it does that in a traditional multiplayer game, the experience sucks. But this is the reality of the way in which the internet was created. So problem number one, the internet wasn't designed for allowing for 100,000 or a million or 10 million people to interact with a single piece of 3D content. Problem number two, and this was the one that we specifically set out to explore, was that if you were to try to do these things centralized, the way in which you would attempt to resolve it is through cloud gaming. So how do we avoid the network mesh issue? Well, imagine if 10,000 people all connected to one server, that server did all the calculations there, didn't have to share the information, and just sent it out as video to the end user. Now I don't have to route packets left, right, up, down, right? We're all in one machine. Think of it like Mario Kart, where we had 4 players playing split screen, but done to a wide extent. That was the kind of work we were doing at Shinra when we were working at Square on cloud gaming. It works. Problem is that cloud gaming is very, very expensive. And also, the further away you are from the server, the more your latency is bad, because now you're dropping frames instead of just dropping positional data. That is a very hard problem to solve. And even the way in which Stadia operates or other cloud gaming platforms have operated don't necessarily solve for the problem I'm speaking about, because what they did was drop games on edge servers to optimize for latency. And so now the server is very close to you. Problem is, if the server is very close to you, you haven't solved your centralization issue. All you can do is play the exact same game you could play on a game console or PC today, just without owning the hardware. And of course, we see that in the limitations of Luna and Stadia and other cloud gaming platforms. So we had been working on this hard problem for a very long time. And one thing happened that we didn't expect when we started doing the research on this, at this point 12 years ago. And that was the advent of the live streaming platforms. We started looking at cloud gaming. Twitch didn't exist. Justin TV didn't even exist at that time. YouTube didn't have live streaming. Facebook didn't have live streaming. And then one thing happens that really surprises me, and that's Twitch plays Pokemon. Here is 1 million people concurrently playing with a single game over a stream, nothing installed on their machine.
Wait, can you elaborate what happened? What was that?
Sure. So Twitch Plays Pokemon was a phenomenon where somebody put a game of Pokemon over a stream and read chat commands that allowed the audience to go up, down, left, right, B, A.
Wow. Okay.
And over the course of several weeks, these 1 million monkeys at 1 million typewriters actually beat the game. And the memes and the stories that came out of this community fascinated me. Here was probably the first time in history that 1 million people collectively beat a game together. And they did so over a stream, which means it was technically a cloud game. Nothing was installed locally for them. And so what did they do here? They kind of resolved a lot of our problems. There was a centralized instance of a game. It was streamed, but the stream wasn't necessarily focused on latency and your ability to have Twitch-based gameplay. It was focused on your ability to contribute to the overall outcome. And it was chaotic because the game wasn't designed for that, but it was fascinating. And so in 2016, I start to think about what if we actually designed products where millions, tens of millions, hundreds of millions of people could interact with that same piece of content, and we'll do it over a stream. And so that led to, for example, titles like Rival Peak that we produced for Facebook and others that we're working on that allow for the first tests of what I'll call metaverse-based design. I'm happy to speak more about what I mean there.
Yes, please. Can you tell us what Rival Peaks look like and then also what other ideas you guys are brainstorming?
Sure. So Rival Peak was an interactive reality show that began its first season in December of last year and ran through the spring, where we had 12 AI characters, and the audience every few minutes was able to tell the AI what to do. The AI had their own goals, they had their own agendas, they had their own storylines, and they had activities that they could perform. And the streams, similar to Big Brother, were available 24/7 for you to be able to affect. And also similar to Big Brother, we had a weekly TV show starring Will Wheaton that kind of summarized what the audience did and drove it forward. By the end of the first season, in spring, we had hundreds of millions of minutes viewed, millions of users, tens of millions of interactions, over 1 billion points scored by the community. And every week, we eliminated a character based off of what the audience engaged with. There wasn't a vote. The audience actually wasn't that interested in voting, which was a very interesting piece of data that we got out of this. But they engaged, they watched, they helped, they supported, and through those supports and interactions, they generated score. And the character with the least score every week, we kicked off. We had no idea who would be booted off every week. We had suspicions. And many times those suspicions were wrong. Every week we are literally editing the scripts, changing animation, adjusting what's happening, and filming with Will on Mondays based off of what the audience did. We had no idea how it was going to end. We knew that they would find the top of a mountain because we programmed that. We knew that they would find an underground city. We weren't there to try to let the audience, blow things up. But who would do it? How they got there? When they got there? We weren't in control of.
And I'm still trying to get a clear picture of how the audience input actually contributed to the actions taken by the characters. What if people had conflicting inputs? What would happen?
In the first season of Rival Peak, the way in which we structured it was that the AI did what the majority of users wanted unless it was strongly against their own AI preferences. So let's imagine that the AI was fairly antisocial and you told it to go be social, but you only had a 51% audience kind of request there. The AI may not have listened. If it was 80% or 90% audience push, the AI would listen. If it was already inclined to do that, 51% would be fine. And so in the case of Rival Peak, it is simple decision making. The next evolution of this, the first of which should launch next summer, will turn this on its head. You will actually be able to have direct agency if you generate enough interactive engagement with it. You'll be able to want to make decisions. You'll see more about what that happens next year.
Wow, that's fascinating. Just the idea that there is almost this multi-dimensional decision making. So there's the audience input, there's the game mechanics, and then also there's the actual agency of the AI to determine how they want to consider the input is scary, but very entertaining at the same time.
Possibly the start of Skynet. We're not really sure yet. But yeah, this was a first iteration. And what's also important is only one shard, only one world, tens of millions of people, but not tens of millions of instances.
Right. And so that actually leads us to a good point, which is this is kind of the current state of computing, right? We are still stuck in this intermediary step between a very asynchronous sort of one-directional way of data transfer, and we're trying to move it towards this pure, perfect, concurrent experience. Can you walk us through a little bit of other examples of platforms that are trying to hack it, how they're trying to hack it, and then we can also get into, what are some potential solutions? I think the Fortnite concert was a really good example of a good hack, but let's walk through that.
Sure. So when you're watching one of the Fortnite concerts, you're actually one of about 49 in a room, and let's say there are millions who are in the concert, they're all kind of in their individual rooms. It's like if we were at Madison Square Garden and each one of us was in a skybox with some others, kind of watching the same thing, but mostly interacting with the people around us, isolated from the rest of us. And they do this for a variety of reasons, but the primary is, at that level of scale, allowing for you to change your camera and move around your character and share with the other people in your room where your character is and what they're doing has limitations. One of the reasons they can do 100 in Battle Royale is you're mostly starting far apart from each other. The closer you get, the closer the server has to, at very low latency, precisely match your interactions. And that's actually very hard to allow for 50 people in the same kind of small concentrated viewing place to all be able to jump up and down, raise their hand, and emote and synchronize all of that visually is intense. There is no easy solution for that yet. There are a number of companies that are exploring this. There are companies that have been trying to redo the way in which game engines network so that they play different kinds of traffic cop. They're trying to split that networking so that you could have, let's say, 100 game instances all kind of trying to generate the same room together and share that processing power. Some of these will eventually break through. I think that we will resolve a lot of the game engine scaling in the next 5 years. The bigger problem that will take probably a decade or more to solve is how we rearrange the internet so that if you and I are in this giant supercomputer network of game engine instances that are in the world 5 years from now, and I'm in New York and you're in Los Angeles, that your latency doesn't suck and you don't have drop shots and other things as a result of that. Because the networks of today weren't designed for this. When you do a Zoom call, the internet wasn't designed for that. It's a bunch of hacks that we've put together. But the better that real-time communications gets, the more networks will invest into this, the more we'll solve those problems, but it will take time.
Well, that kind of brings me back to a question around decentralization, actually. So there was something that I read about how people are thinking about like all the inactive devices that people have and how to leverage that as computing power that we could potentially have to power these experiences. And there was talk about blockchain concepts where, could we be able to seamlessly transact and loan out different parts of our devices and get paid through cryptocurrency for the usage of that device. What do you think as a concept of hacking this problem right now? Is it legitimate in any way, or do you think it's a dud?
If you look at something like folding at home, which doesn't need a real-time output, that is basically what is being described, though the confirmations of those transactions are happening through blockchain, which I can understand. None of that resolves for real-time multiplayer. Mm-hmm. None of the problems that I've just described get resolved through further fragmenting of where processing power happens. And let's imagine that I need to communicate to you that I'm about to shoot a bullet, and that has to happen in true real time. Mm-hmm. And my phone was being used to help calculate that, but I decided to use my phone. Is it acceptable that my bullet shot just gets ignored and not processed anymore? No, right? So none of the real-time multiplayer issues can be resolved through that kind of description. I can understand non-synchronous, non-real-time processing power stuff, but then traditional cloud is probably cheaper for that than trying to kind of corral all of these devices.
That makes sense. Okay, well, let's switch gears and talk a bit more about this future of concurrency and massive online games that you're talking about, but for more of a mainstream use case. So everyone's talking about the metaverse, not as a game, and you said that yourself as well. It's going to be a world in which everyone participates in. So I'm kind of curious to hear about the use cases that you think are ripe for disruption that can take a lot of these game mechanics and then apply it to other verticals.
For me, the general kind of direction is we will spend more time in 3D rendered space than we do today. That doesn't mean that you looking at a phone and checking your social media feeds or reading your email happens in 3D. I'm not sure that that is a better thing than what we have today because the human eye just reads flat information and text more simply. But what it does mean is that the time that you spend inside of a game or inside of some sort of work environment may be simulated and 3D rendered at a high visual fidelity, and you may spend much more time of it than today. So you can attend a Zoom call in 2D, but you may also be able to simply sit down and be part of that in a 3D environment. A lot of the versions of that today are fairly schlocky. They will get better. It will become very normal for you to spend a good swath of your day in a 3D environment, whether in a game, whether in play, or whether in some other form of socializing. And I see this as a change in the way in which we handle communication, because again, today, text is a significant form of communication, voice chat is a significant form of communication. That's still the way in which we will speak, but we may be staring at, interacting with, or moving through 3D rendered spaces. And that's the way in which I see that evolution happening. And I don't think that we're prepared for the scale change which is required to enable that.
And scale meaning all the multiple inputs that every single person is going to contribute, right?
Precisely. Exactly.
And what does that look like? If you were to describe what will be happening and why we can't field the load, what's the issue there?
The issue is the same one that I addressed when it came to the Fortnite concert. When you play an MMO, you pick a server the first time, right? Mm-hmm. You could be on the Ragnarok server. You could be on the Valkyrie server. If I'm on Ragnarok and you're on Valkyrie, can we see each other? No, We can't see each other, right? And so I don't think that this works if we all have to be in predetermined locations and we have to move our characters from server to server world every time we want to engage. If you look at Zoom or Google Meets today, they max out their real-time video conferencing at 200. If you try to have more than 200 people, they force you to broadcast. It's the same thing I'm doing with Miles. Video is the only thing that actually scales to millions of concurrents, interestingly enough.
Right.
But returning to the question, I don't know that it's 300 people or 400 people in a single room that's going to be the defining thing. What I know is that you may be in a shared space that needs to be seamless and needs to allow for people to come in and out seamlessly and be able to interact and engage with each other seamlessly. And that can't happen when I have to load up and jump into an instance, transfer and move servers, and deal with the fact that, again, you're in LA and I'm in New York, and we're just not interacting with each other at the level of latency and visual fidelity that we want.
Do you think that's a case for platforms like Discord, Twitch, probably still being in their heydays for a very, very long time?
I think that they'll be there for a very long time. I think that there'll probably also be identity systems for these experiences.
Explain that a little bit more.
I think that this is one of the primary reasons that Mark Zuckerberg's been interested in the metaverse for a very long time, which is that a lot of this is strongly connected to your individual identity. What kind of avatar are you going to have? Who are you going to be in this 3D rendered space? And what account system will you use to be part of that identity? When I play Fortnite, I have actually many different account systems. I play it on Xbox, I play it on PlayStation, I have it on Switch, and I have it on PC. All of those connect to one single Epic account system, which stores my information. But there are many gateways into it. There are many platform holders. That won't change. You may be able to log into it through your Discord ID. You may be starting by watching a popular streamer on Twitch and jump into it just like you do a traditional game today. Link your Twitch ID to the account system of the experience you want to be part of, and it should be seamless. We know how to get there today. These aren't hard problems, but that question of which platform is going to be one of the primary sources of identity is, I think, the one that Mark is kind of really focused on and why he wants to be there first.
Yeah, let's elaborate on that more. So I think there is a question around interoperability, right? Immediately when you say identity systems, a lot of people who are like the core metaverse gaming group, they're on Twitch, they're on Discord, they might not value their Facebook accounts quite as much. And so tell me what you think about Mark Zuckerberg's plan in moving towards the metaverse and whether or not they'll be successful given that they're a very centralized, closed network.
Let's look at the question from two perspectives. One, what do I think the advantages or disadvantages in big tech are when it comes to metaverse? And then two, specifically to Facebook, where do I think those advantages and disadvantages are? I'm going to start with the former. One of the things that many people don't know or understand are that most of the big technology companies operate significant fundamental layers of the internet today. That will not change. We saw this when Facebook went down earlier in October. You couldn't log into Pokemon Go. Why? Because that identity system and that API call was broken. Whether it's Google, Amazon, Apple, etc., they own millions of miles of dark fiber. They've invested into this, undersea cables, etc. Many of the APIs that we call to log into products, to understand how a product should work and or which kind of allow for software that we use over the web to operate, are connected to those companies. If AWS went down, a wide swath of the internet would go down. And it's not just the server infrastructure. As I said, APIs, drivers, these technologies form a backbone of a lot of software that we run off of. You cannot run a 3D game on an Apple device if you're not using Metal, which is their 3D rendering technology. Isn't permitted. Doesn't work. Metal went away. No 3D games on an Apple device. Right? Same thing. You want to run a 3D game on your computer? DirectX. Microsoft's invested into that for decades, 20 years plus at this point in time. Similarly, Facebook, Google operate many of the APIs that programs that we call work off of. There is no resolution to that. There was a reason that people started using them. They work, they're stable, and for the most part, they're free. If you're a business and you're trying to grow your business, what is better than those three, right? And so could you resolve some of this with open consortiums? Maybe, but the trajectory of the last 20 years hasn't been that. HTML5 took a decade to resolve and instill on many devices, broken and or gate-kept by, for example, the fact that Apple has not invested as much as it should into WebGL2 and other technologies to allow us to use mobile browsers properly. Why do you think Fortnite isn't running in a mobile browser? When a company like Amazon decides to throw 3,000 engineers to get you an API that you need, and it's good and it's stable and it works, and the other one could be there in 3 years or 4 years, you need to build your business now, which is why these things get done the way that they get done. Because if you are a small software developer, or medium software developer, or even an enterprise-level software developer, there used to be a phrasing, no one got fired for choosing IBM. You're not going to get fired for choosing really stable, good-to-use, easy-to-access APIs. Now, there is a contingent of the community that is vehemently against this. That has been the case since the open source software days. That has been the case since Richard Stallman and the others believed very strongly in open source, decentralization, open efforts, foundation of what the kind of Linux community has been about for a very long time. But even then, you've got companies like Red Hat that get built based around this open source software foundational efforts because other businesses need to build off of something where if there's a problem, I can pay for someone to fix it. I can't wait for a consortium to maybe fix it for me next year. And so these are real issues, and they're one of the reasons that if you look at the Metaverse ETF that Ball and I worked on, a lot of the top companies there are NVIDIA, Facebook, Tencent, others. They just own a wide swath of these APIs and technologies. When you have a GPU, if you generate any kind of 3D rendered game today on an NVIDIA device, which is a device that underlies a lot of the 3D rendering in the world today, you're using an NVIDIA driver. Can't use an AMD driver. Can't use an open source driver to access that. That driver is a moat around their hardware, around their business. And they do that intentional. Those drivers are great. They allow for amazingly complex worlds, hair simulations, AI, all sorts of incredible things. Their investment in software is astounding. But it also means that hardware isn't the end game here. It's about how you can create the things that people connect into and make that the most kind of sticky part of your business for them to change.
I think that's a really shrewd way of actually thinking about it. I don't think that's the way most people are perceiving when Facebook says we're going to be a part of the next metaverse vision. This is how they're going to play a role. But it makes sense. I mean, they are the infrastructure of the internet in many ways.
They are. And their identity system is core to so many applications. And it makes sense. They are the largest platform. And despite the concerns that many people have with regard to their utilization of data, which I understand, their security around that user data is considerably higher than me starting my own company and asking you for user data, because they have invested billions.
Can we talk a bit about the other side of Facebook? So Facebook Reality Labs, Horizon, VR, AR still, and this whole Oculus obsession. Does that play a role, or is it just a facade?
I understand why they've gotten there, which is to say the greatest existential threat to the company is the fact that Apple and Google own the hardware and gatekeep the software that most of their customers access the platform through. So if you have a strong belief that virtual reality is a foundational technology to the metaverse, then your ability to own that hardware and software layer is the right strategy to take. I personally have a different view on whether they are foundational. I consider them to be kind of side attributes, other ways to enter it, but I understand why they have that perspective. It makes rational sense if you think that VR is going to be a foundational part of the metaverse. It's just not something that I agree with.
I mean, maybe in a really far future world where high fidelity experiences output is really important to people.
Yeah, but in my opinion, I'm going to sound like an insane man when I say this. I think where that gets to in about 40 years is holodecks rather than VR. I don't know.
What are holodecks?
Just like in Star Trek, right? Where we're actually got 3D rendered, projection mapping stuff in front of us. Whether we can truly interact with that or not, I'll put aside for a second. But my fundamental issue is that I don't necessarily believe that people want to, in the case of virtual reality, wear a thing on their head. Or B, in the case of augmented reality, hold a phone in front of them or just constantly have glasses turning things on and off for them. But I think that there are going to be settings, places where you would go to that have projection mapping cameras that allow for you to interact with 3D worlds that are literally in front of you. I think that that's where it goes in 4 decades, not necessarily us continuing to wear helmets.
I totally agree with that. Well, this is a good segue to my last question for you. How do you think the metaverse is actually going to be different than real life? Because there's so many ways in which it's more sophisticated, it's going going to be more intelligent, that networks are going to be far more superior. So paint us a picture of that.
I think that the fundamental difference is today when you're in real life and you're engaging in work or even in a conversation here, what we look like is defined by our physical appearance. I think that shifts. In Fortnite, I play as Harley Quinn, or I play as one of their new characters. I play as Jonesy. I play as Batman. I can kind of be what I want to be. It's like Halloween 365. I think that how that shifts our identity, what we think about as identity, how that contributes to the way in which people visualize us through work, changes fairly radically. I'm very interested to see where that takes humanity.
And what about the role of AI? And given how much training and inputs they're going to receive from future worlds that we're going to create?
The most careful work we need to do in the next 20 years is to eliminate a lot of the biases that have been put into AI. If we don't do that right, we're looking at a much more dangerous world. If we do it right, we're looking at a much more equal world. So how we train those machine learning sets, what we program AI to do, I think will change a lot of the way in which we interact as people today, and will certainly be the case in the metaverse where you may not know if a person's an NPC or a real human. We'll see. The other thing that I would say here is that if you look at the way in which we train artificial intelligence today, most of the time we're training them to do tasks for us, to interact, to be a chatbot. But the more crucial decisions are being made in places like actually Tesla and others where they're training the AI of their car. If the decision of the car has to be hit a person on the street or hurt the driver by slamming into a wall, which should it do? These are scary, real decisions that these programmers have to make. These moralistic decisions, I think, are the most important trainings that we're going to have to do to AI. And that's one of the reasons that ethical AI debates that are happening at Google, Facebook, and other places are incredible importance, because those companies are the ones who are training that AI today.
Absolutely. Well, thank you so much for your incredibly grounded, researched, and rational perspective on the metaverse. For people who have not read the primer, go to Matthew Ball's essays. It's called the Metaverse Primer. Really great explainer of what the metaverse is. Thank you so much, Jacob, for being here today.
Appreciate the time. Take care.
That was Jacob Navok. You can find him on Twitter at @JNavok, or you can check out some of the new gaming experiences that Genvid is powering on genvidtech.com. If you like this episode, tell a friend about it, or hit that subscribe button. I would also really appreciate if you left a review. If you have feedback or ideas for topics or guests to bring onto the show, please email me at annie@hellometaverse.fm. Thank you for listening. This is your host, Annie Zhang, and I will see you in 2 weeks.